Okay. Good, great. My name is Daniel Ryan. I work for a company, ProcessMaker. Thanks for coming to the talk. Title of this talk is Building and Managing a Secure Multi-Tenant Trial Infrastructure for Open Source Software in the Cloud. It is quite a mouthful. As I mentioned, my name is Daniel Ryan. I'm a Cloud Operations Engineer with the company ProcessMaker. Just to give you a quick background on myself, I started off as a network engineer, actually, working for a CDN, Content Delivery Network. Did that for a few years. After we were acquired, I started moving more into DevOps and CloudOps. And now I'm currently working for the company ProcessMaker. And just to give you a quick background on what ProcessMaker is, we are a company that develops an open source product that is used for BPM solutions, so that's business process management. So anything that requires a process or communication or things being transferred between departments, this can all be automated within our platform. So that's just a quick background on myself. So let's just jump right into a use case. So you're an open source company or developer and you've developed your open source application and you want to automatically and securely deploy this to a cloud such as AWS and make sure it's completely secure and scalable. So just kind of jump into some of the common points that people look for in deployments. First is automatic deployment. We want to make sure that everything is done automatically, as little hands-on as possible from your operations team, reduces human error, and gets things done really quickly. Second is securely segmented data. So when spinning up different trial instances or any instances for a customer, you want to make sure that this data is completely segmented from other customers, from core code, just to make sure that everything is securely locked down. Scalability is a big one. Obviously, you want your automatic deployments to continue working. You don't want something to just stop breaking because of something like resources. So scalability is a big one. And then finally, cost effectiveness. So you want to make sure that whatever you develop, whatever you have in mind to fix the problem and solution, come up with a solution, you want to make sure that it is cost effective. So let's jump into how we were doing it as a company before. Usually, before you have all this automation, there's a lot of manual work that's involved. First is interdepartmental dependencies. So the problem with this is communication. Before, when we were doing these trials, a customer would come in, reach out to our sales department. Sales would say, yeah, we can get you a little instance to play around with. Sales would reach out to the cloud department. Cloud would spin it up with whatever the enterprise package is, things made for the customer. We would have to reach back out to sales. Sales, give the thumbs up, things are ready to be done, and then sales has to contact the client that had made the original request. So in that time frame, there's a lot of things that can happen, including the client finding another solution. So this process would take quite a bit of time. Next was manual builds and deployments. So as we were deploying and building these instances for a client with all the bells and whistles, we had to build each package individually for the client and then include the specific parameters, anything that they wanted special for them. And then after building it, we would have to manually deploy it all. So you'd have to move all the moving pieces into a trial environment, make sure it's completely segmented from any other customers, make sure that the database is isolated, and so forth. Another part of the manual process is cleanup. This is kind of something that gets lost in the cracks. If someone, has a trial for 20, 30 days, working in the tech industry, 20, 30 days seems like a lifetime. There's so many things that come up, things get lost, and cleaning up a trial is going to be the last of your concerns when you have real things that you need to do for your business. And then finally, as I mentioned, time consuming. So you'd be spending all this time spinning up a trial that, in all honesty, isn't making your company any money. It's just there to help determine whether someone wants to use your product. And all this time that was put into this can be better placed elsewhere in something like a more pressing project. So these are all the things that how we were doing before, manual process, take forever, just kind of all over the place. We had decided we had to come up with something that what we wanted to fix these issues that we were running into. So the first thing we wanted to do, automate anything and everything. So we don't want to be involved in this we didn't want the operations team involved at all with any trials coming up. So the first thing we needed to do was automate the requests. So rather than having a potential client reach out to our sales department and go through that channel, we decided to create we wanted to do something to where a client can just fill something out and then have the wheels rolling. The next thing that was something that was important to us was Salesforce tracking. So I'm sure a lot of you guys are familiar with Salesforce. Our sales team uses this to track any potential customers, any current customers. We wanted something that would be able to involve the sales team without having the potential client have to reach out to them directly. Third thing that we wanted was a full enterprise deployment in the cloud. So we like to keep things in the cloud. It's easier to maintain. We do have an open source. It is an open source product, so you can go and download it and run it locally on your own machine. But having everything in AWS would give us more visibility into things that were happening. If we ever needed to change anything, we could do it. And we wanted to make sure that this was all deployed with all the bells and whistles and full enterprise deployment. And then finally, we wanted to do automated cleanup. So something that no one really wants to do is go back and delete things and just clean things up. There was a lot of cruft, a lot of just technical debt that would come up. So we wanted something that would be able to go in and clean up any trials that really didn't need to be there anymore. We had met as a team, as a company, between the cloud team and the sales team, and decided maybe 30 days is a good amount of time. So what we built, this is actually what we decided to go with. So we went with automation from request all the way to the running application. This is kind of an overview, top-level overview of how things happen. So first, we created a form, like I mentioned, in our on our main website. There is a form that you can fill out. It says request an enterprise trial. Once that form is filled out, we have it send all the information over to Salesforce. So this is kind of hits that first point that we were trying to do. Though we were taking communication away between the potential client and our sales team, we wanted to make sure that the sales was informed about every potential client that spun up an instance. So the first thing that happens is when they fill that form out, a query is sent over to our Salesforce application. All of that information that they send in, address, date, all that good stuff, is sent over to Salesforce and recorded. Salesforce then sends an API request to our AWS API endpoint. So it will send the necessary information that we need on our side, which is their email and the workspace name that they decided on. We decided to use AWS Lambda. For those of you not familiar with it, it's just serverless, being able to run functions and scripts serverlessly without having an EC2 instance of. I'll go more into why we decided to pick up on Lambda. The next thing that's done is we needed to make sure that we wanted to create a unique URL for the trial customer. So we didn't want to just give them some random string or something to type in. We wanted them to choose their workspace name that they wanted and be able to use that in an own unique URL that they could go to and play around with our application. Next, we decided we wanted to have all this running for our segmentation part that I mentioned before to make sure that it's full multi-tenant and all the code is segmented. So we decided to have each instance brought up in its own Docker container. So allowing us to use Docker containers is a way to spin up the core code with the necessary things for that potential client and have it completely isolated from any other core code, from any other trials or any other moving parts. I'll go into a little bit more detail on why we decided on ECS. Let's see. Next, since we use a DNS wildcard for the subdomain, so when you choose a workspace, it'll be the one you chose, .trial.processmaker.net. So in order to properly route those requests, we use AWS load balancers and target groups. So this will give us the ability to, we have, at one point we had like 2,000 instant trial instances up. Even though they all use the same top level domain, being able to use load balancers and target groups, we could properly route to the correct correlating Docker container that they spun up. And then finally, we decided on RDS as to host the databases, and then the data is imported. So RDS is nice because you can have a multi-region solution, so it's highly available. All the instances are also segmented from each other, so any customer information or any data that they inputted, which was saved into a database, would then be completely isolated from anybody else. So this is what we decided on. This is kind of a high-level overview, just kind of what it looks like on a graphical level standpoint. The left side, you can see the actual creation trigger. So the workspace is created through the form, hits the Amazon API gateway. This triggers our Lambda function, which then creates the necessary DNS name, the necessary application load balancer rules, spins up the container within ECS, and uses the MySQL serverless as its backend. So as I mentioned, we are an open source. We do have an open source product. So you can go and download it right now from our GitHub. We utilize GitHub and Docker Cloud so that anytime we need to make a change to our images, or if we made, there's a new plugin that we want to add so that customers can now try this new feature that we've come out with. It's very simple. We just make the change to our necessary repo in GitHub. Docker Cloud pulls it down, creates the Docker image that we need. All future ones are going to be done on that new image. On the right side, this is kind of how users actually access their application. So you can see the end user just hits the domain name in their browser, which gets forwarded to the application load balancer, which then picks the correct corresponding container for their instance within the ECS cluster, which then talks back to the MySQL backend. So this is kind of a high-level overview on what we ended up doing. So why did we move to Lambda for serverless functions? So you don't need a server just sitting there to handle one-off requests that come in, intermittently. This server would have just been sitting there, waiting for someone to make a request, accruing costs, and just creating technical debt that we did not want. So with Lambda, it's nice, you can bring your own code. So regardless of what you code in, whether it's Python or Go or whatever, you are able to create your function, and they have the compilers right then and there, so it will actively read your code, compile, and run without the need of having an EC2 instance. So yeah, you can choose your own flavor, very nice. Also, they have a very easy, simple resource model, which is very, very nice. You don't have to go in like EC2 if you're familiar. There's all these different types of instances. There's memory optimized, compute optimized, database driven optimized, network optimized. With Lambda, you get a nice, simple model. You can choose how much memory you want to dedicate to this function, between 256 and 1.5 gigs. And then the CPU and network resources are all automatically allocated as necessary. So if you created a function that seems to run kind of high load, creates a lot of CPU power, it will scale as you need. Also, another nice thing about Lambda was the metric logging. With Lambda, maybe not so much in EC2, because you are able to get a few information from CloudOps, memory, load, things like that. Within Lambda, though, you are actually able to see exactly how much memory is being used on the function, how long it took, what the network cost was, what the CPU cost was, etc. And this seemed to be really cost effective for us. We did some numbers versus running a very T2 micro EC2 instance, some tiny little thing that would just be sitting there, and this was very cost effective for us. So this is why we ended up moving to serverless functions. We also use Lambda for cleanup. So another thing about Lambda is using Lambda in conjunction with CloudWatch, you're able to create cron jobs. So as I mentioned earlier, we have a 30-day trial period. So all we have to do is create a simple Lambda function that will go in, runs every day, 1:30 in the morning, checks for any instances that were brought up in our ECS cluster within the last, or older than 30 days, so 31 days and older. And we'll go in, terminate, delete the data, remove all the DNS rules, the load balancer, the target group, etc. So this is an easy way to run a function on a time basis, because cron jobs are super helpful. You're also able to do things by event pattern. So if a certain event that you created is done, you can have it schedule another Lambda function. So for instance, if we can create an event pattern that says if a Docker container is brought up within our ECS trial cluster, hey, maybe we want to send an additional email to this person, or we want to run this other Lambda function that does this. So not only can you do cron jobs and such with CloudWatch, but it's also nice because it's an event-driven thing that you can create as well. So why do we decide on ECS? So we had decided to, our normal process for deploying a fully loaded customer is not done in Docker containers. It's actually done using the full server. We didn't want to do that. We didn't want to just have it deploy code and stuff. We wanted everything to be nice and neat in a little Docker container. So allowing that changed it from, if any of you are familiar with like Ansible or Puppet, something like that, where it actually goes in, SSHs or talks with its agent living on a server, deploys necessary configurations and such. We didn't really want to do that, as that can be time consuming and you're kind of relying on a lot of moving pieces. So we decided on containers. And with these containers, they spin up very quickly. This also gave us a lot of ability to modify our Docker images. So as I had mentioned, all of our things are hosted in GitHub. If we needed to change something, add an additional enterprise plugin, maybe change the version, as we're always updating our version, we can just do this in GitHub. Docker Cloud, Docker Hub would pull down the image, or pull down the repo, build out the Docker image, and then all future ECS containers that were deployed would use this newer image. You can also easily scale the necessary resources within ECS. So ECS has a couple different options. You can either use a serverless backend, or you can use EC2 instances. Since we had this going for a full 30 days, these Docker containers actually running for full 30 days, we decided on using proper EC2 backends. When doing this, you can easily change how you want it to scale, whether that's CPU bound, memory bound. Our application happens to be a little bit more memory intensive, so we decided, once there's only a gig left in the server, we want you to spin up another EC2 instance. Bam, no problem. So any future containers that are brought up, just hit that new EC2 instance. So yeah, very easily scalable, very easily modified, and very fast. So this is why we decided on ECS. So I'm just going to quickly show you kind of what it looks like here, assuming it all works. So rather than filling out the form, I'm just going to manually hit the API here. And it's going to take just a minute. And basically what I'm doing here is, already finished, great. So you can see here we get a 200 response. It's nice and neat, gives you a workspace header. So this workspace header is what I mentioned would be what a potential client, when they sign up, they say, we had someone from Tesla that was looking at it, so they would create a workspace with Tesla. So they would just go to the tesla.trial and it would all be spun up. So I've done ATO test 2019. Let's take a look on the actual logging side of that. We use CloudWatch Monitor, so everything, we're an AWS shop in case you hadn't noticed. Everything we do is in AWS when it's done in the cloud. So you can see here, there's a new event that was done here at this timestamp, which is us right here. And if we click here, we can see status code 200. We can see exactly how it was done via curl command, and we should be able to see. There we go. So you can see the curl, you can see it's done over HTTPS. Here are the parameters that were passed, the email address, the workspace, etc. So a nice thing about CloudWatch is that you can create all these logs yourself. You can choose exactly what you want to log on. It doesn't have to be this detailed. It could be simply a container was spun up with this name. This was done. So it's super handy. Let's look at the ECS side of things. So this is our little cluster here, the trial test cluster. And this is where the actual containers are being spun up. So let's get us to test 2019. And should be able to see it here. There it is. So let's take a look at the service. And when you spin up a service inside of ECS, what it does is it will create tasks. So you can choose how many tasks you would need per service. This would, let me click on the tasks I'm talking about it. Here it is. So here's the actual running task. So this is the actual container being spun up in ECS. Let's take a look at it. Get some more information. And you can see here, this is the its running state. This is the image I had mentioned. So if you wanted to do something like a web servers automation, you just point it to like Nginx's or Apache's Docker Hub and choose the version that you want. You can do hard and soft memory limits, gives you resource IDs, etc. You can also see, so if you want to check back to exactly which EC2 instance this is done to, we have your IP addresses here. So if we want to actually dive into the container that was spun up by this potential client, we can SSH into the EC2 backend that's actually hosting the service, and directly, Docker exec into the bin bash into the container itself, so we can poke around. So let's actually take a look, make sure it's up. Oops, not this one. Test 2019. And normally, when you go through the whole process of filling out the form through our website, it'll give you a nice little email, welcome email, saying, "Hey, your container's being spun. Just wait a few minutes," and then it'll send you back the password along with a URL. So let's just make sure that we're up. We are. That's great. Now I should be able to log in, no problem. And it should ask me to change my password. There you go. Great, and so now we have our applications being completely deployed to, this is running on AWS inside the cloud. It has its own unique DNS URL here. And we have all of our nice packages all done and set up. So that is nice that worked. So let's, oops, I'm missing a slide. So let's talk about cleanup. The way we do cleanup was, as I mentioned, through trials, through the Lambda function on a cron hub. So 31 days from now, we'll have our function will run. It'll see that this was brought up past the limit. We'll go through, check everything, make sure it needs to be cleaned up, destroys everything, make sure there's nothing additional there. Great. And I know it's getting late, so I'm going to make this nice, short, and sweet. And thanks for coming. Anybody have any questions?